Hello, PLMS. Today we're going to be finding slope given a graph. Our objective or I can statement for the day is I can find the slope by looking at a graph. Slope is rise over run. Rise is going to be the change in the y's, and the run is the change in the x's. Note, if a graph has a positive slope, start low and count up. If a graph has a negative slope, start up and count down. We know that a line is positive when it's going up like this, and it's negative when it's going down. So if it's positive, we're going to start low and we're going to count up on the line. And if it's negative, we're going to count up. We're going to start up and then count down like it's a mountain. Here's our first example. Find the slope of a line. A good starting point is always to look to see if it goes through the y-intercept, and this graph does. It goes through the y-intercept right there at 0, 0. So in order to count, you have to have 2 points on the line. And so you're looking at a place that the line crosses an intercept. An intercept would be an x, so like any of these lines, and this is our y-intercept, so any of these lines. So we're looking at a place that the graph crosses that direction. So I know that it goes through the origin. So you can see that the points are already highlighted in this example. So we're going to use the rise, and we're going to use the run. So from this position, then from the origin, we're going to count up 1, up 2. So that's going to be the rise, and then I go over 1, 2. So as far as that's concerned, I want you to recognize something else. First of all, 2 over 2 simplifies down into one whole. So also that tells us that really this graph went up 1 and over 1, and that process repeats itself. Now, why did we write 2 over 2? Because that happened to be the 2 points that were highlighted. Sometimes you're going to be given a line and you're just going to be told find the slope. Sometimes you're going to have those points highlighted as you did in this example. So do make sure that you simplify down to 1, and I want you to start using m is equal to, because m is going to be our slope. In the next example, you can also see that points are highlighted on the graph. We're looking at a place where the graph goes through an intercept. In this case, I notice that the line is going down. So if the line is going down, my eyes are counting from one of the points that's highlighted to another point. Now, I see that these 2 points are highlighted. I'm going to go ahead and make those blue now for you. But also the graph goes through this point up here. And so you can choose the points that are already highlighted for you, or maybe you identify your own. I'm going to go ahead and work with the ones that were identified originally. So we're looking at this point and that point. So I notice that it's going down. I know it's going to be negative. So I'm going to just go ahead and write that because I don't want to forget that the line is going down. And I do rise, which rise can be up or down. So you might think of it as an elevator. An elevator can go up or down. And then the run, which is going to be, that's going to be going, left to right. So rise is going to be up and down, the change in the y's versus the change in the x. And I know that I'm going down 1, went down 1, and then I go over from that position, that's 0, then we count 1, 2, 3, negative 1/3. And I'm just going to check to see if that is true continuously. So from this position, I went down 1 and over 1, 2, 3, down 1, 1, 2, 3. And you can see that that does work. So our slope of this line is negative 1/3. I know this one's going to be positive because it's going up. I'm going to go ahead and write m is equal to. Once again, the points are highlighted on this on this particular line. So I see this point and I see this point. So I'm going to count up. We rise first. 1, 2, 3, 4. And I would write that down. And then from that position, that becomes 0. And so then you count 1, 2, 3, 4, 5, and 6. So if it's 4, 6, I notice that that's going to simplify down because 4 and 6 both have a common factor of 2, and that's going to reduce down to 2/3. So how is that possible that it's 4, 6, and 2/3? Well, let's look to see how that works. That means that from this position, from our original position, I also could have gone up 1, 2, and over 1, 2, 3. And that does work, and it continues so on and so forth. Even from this point, I would, let's come back here, I go up 1, 2, and over 1, 2, 3. Now, the first thing you want to ask yourself on this one is it going up or is it going down? And I think that we would all agree that it's going down. That's going to make it a negative slope. So if it's negative, this one's a little different because I don't have points highlighted on the line, so I'm going to have to choose them. A good starting point is to just look at the y-intercept. I noticed that the graph goes through the y-intercept right here at, what is that, 1, 2, 3, 4. And then it also, it just is traveling, it's going, and it's hitting every single intercept. So I only need 2. Remember that if it's going down, we're going to start up and then count down because we know that it's going down. And so if I start here, I'm going to count down 1. So I know it's -1. And then from here, we start and we count 1. And then that process repeats itself. Down 1, over 1, down 1, over 1. So that's -1 over 1. Well, I need a rise and a run in order to count, but the best answer here would really be -1. Final answer. I would stop the video and I want you to pick out 2 points that are intercepts, and then once you have figured out the slope, then I want you to start it back up and see how you do. I mentioned in the last slide to pick out the intercept, so I'm going to, you don't have to start there, but I noticed that it goes through the y-intercept at -1, -2, -3, and then as I follow along the line, I notice that the next intercept is right here. That's a place that the graph meets an x and a y. And then it also meets x and y there. So I'm going to start here. I know it's negative. I'm going to go ahead and write m is equal to negative. I don't want to forget negative. And then I go down from this position, 1, 2, and then that's my -2. And then from here, I'm going to count over 1, 2, 3. And I'm just going to repeat to make sure that I'm right. So from this position, I went down 1, 2, and then this is 0. That's down 2, and then over 1, 2, 3. So our slope of this line is -2/3. Did you get -2/3? I hope so. Then we have some special cases. It's this line, as you can see, is perfectly horizontal. And so if a line is perfectly horizontal, this is what I want you to think of. I want you to think that a man or a woman, a person could stand on this line. Imagine a person who is trying to ski, and they can stand on this line. And so we say that the slope of this line is 0. And what I think of is that it's 0. I'm not going up, I'm not going down, but I can in fact stand on it. And if I was trying to ski with my ski poles, and I imagine that I could actually stand on that line. So we say m is equal to 0. Then we have a perfectly vertical line. And you can imagine if I had a little ski guy here, whoopsie, it's not going to look very pretty, is he? He's going to be down here, and there might be some redness involved, that wouldn't be very pretty because he can't stand on it. And so that doesn't have a slope. There is no rise and there is no run. It's just a fall. So if you would just fall, then we're going to say that m equals undefined. Also, this tells us that we cannot have a 0 in the denominator. So that if you ever end up with a 0 in the denominator, then that is also undefined. And when you start to do your calculations, that's going to happen. So just to review, if it's horizontal, m is equal to 0, and that's different than if it's perfectly horizontal, it's m is equal to 0. If it's perfectly vertical, meaning up and down, then we say m is undefined. I hope you enjoyed your lesson on finding slope given a line.